Welcome to Ms. Taylor's class notes, and today we're going to talk about continuous domain and range. So the biggest thing about continuous data is that continuous data are lines, or it is data that can be measured in fractions or decimals. So like half of an hour would be continuous data. 3.5 miles would be continuous data. And the other thing about continuous data is we're going to use inequalities. So real quick, let's review our inequalities. So if we have a less than or greater than, we're going to have a open circle. If we have less than or equal to or greater than or equal to, we're going to have a filled in circle. And so those are the two things that you got to remember from a previous unit. And then occasionally you're going to see me use this sign right here. It is a double R. So it's got two straight marks, and this double all means all real numbers. And we're going to talk about when that happens, but it doesn't happen a whole lot. So let's remind ourselves about domain and range. Domain is always going to be blue. Range is always going to be green. So domain is our X. It is our input. And it is our independent variable. I'm going to abbreviate those. We've talked about them a lot, so we're just going to keep abbreviating it. And then the next thing we need to know is domain is all possible values of X. So our range is our Y. It is our f of X. It is our output. It is our dependent variable. And it is all possible values of X.
Abby Van Leuven, your phone is in the front office. Abby Van Leuven, your phone is in the front office.
So with lines, we do things a little bit differently than we did with data like dots and tables and things like this. So we're going to write our domain and range as inequalities. So I'm going to explain what that means here in a second. But what we're looking for is we're looking for the furthest left and the furthest right that this graph goes. So this -2 is the furthest in that direction that my line goes. And I'm going to trace the line, and then this right here is the furthest to the right my graph goes. So what that tells me is, it tells me that my graph is going to be contained in between these two spots, these 2 points. That's what it tells me, is that my domain could be any number in that range. So the way that we're going to write this is we're still going to use our fancy brackets. Let me get my pencil. Come on now. There we go. We're still going to start with funky brackets, and we're still going to go least to greatest. So of the two numbers that I highlighted, -2 is my smallest number. 4 is going to be my biggest number. So X is going to be any number that is greater than or equal to X, or less than or equal to 4. We're always going to put points, our inequalities, we're always going to use the less than sign when we write it in that inequality. But when we write it or we use words, we're going to say -2 or X. Brain is, we're going to say that the domain is all real numbers, because it can be any number that is real. Okay, NUMB, numbers greater than or equal to -2 and less than or equal to 4. And so that's that inequality statement in words. Is that X has got to be bigger than -2, but smaller than 4. And that's what we're talking about when we are using these inequalities. So now for range is going to go up and down. So this is the highest point on my graph, and this is the lowest point on my graph. So what that means is that our y values or our range is going to be in that spot right there. Our graph does not go beyond or below it. So again, we've got to go least to greatest. So the smallest number, oh, this is supposed to be green. I'm trying to stay in theme. So the smallest number is -3. The biggest number is 4. I'm going to use less than or equal to because it's a filled in dot. And I'm going to use less than or equal to because it's a filled in dot. So -3 is less than or equal to y, which is less than or equal to 4. So again, our words are all real numbers greater than -3 and less than 4. Less than or equal to 4. And so those are the numbers or the words that go with that statement there. All right, so let's look at another one. So again, domain is our x, range is our y. So domain is x, so that's our x-axis, so that's the furthest to the left I go and the furthest to the right that I go. My range is our y, which is up and down, so the lowest that it goes is there, and the lowest or the highest that it goes is there. So, fancy brackets, my smallest number for domain is -2, less than or equal to, because it's a filled in circle, x, less than or equal to 7. Again, less than or equal to because it's filled in. So for range, I'm going to take the smallest number, which I highlighted, which was -3, less than or equal to y, less than or equal to, and the biggest number I highlighted was 6. And both of those were filled in circles. Ooh, that's really, really bad. And so that's what we're looking at right there. So again, if I were to write my range in words, the range is all real numbers greater than, because it's got to be bigger than -3, greater than or equal to -3, and less than, because it's got to be smaller than 6, or equal to, less than or equal to 6. And so those are the words that match this inequality. All right, so I want you to do this one on your own, and I'm going to draw your attention to, we have an open circle here, so we're going to use either less than or greater than, and we have a closed circle here, so it's going to be less than or equal to or greater than or equal to. I want you to try that one on your own and check it with your class notes. All right, so this one is a little bit different because of this arrow right here. So I'm still going to look at my x-axis and what's the furthest it goes to the left, and that's going to be that point there. And the furthest that it goes to the right is going to be that arrow there. For range, what's the furthest it comes down, which is 0, and then the furthest that it goes up is that arrow there. So if we have one arrow on our line, we're only going to have one number in our inequality. So domain is x. So I'm going to put x. I'm always going to start with x when I have one arrow. Is the line getting bigger or smaller than 0? If it's getting bigger, I'm going to put greater than or equal to, and then I'm going to put whatever number my line stops at, which is 0. And so our words for this is that the domain is all real numbers greater than, oh, I can't spell today, or equal to 0. And so for our range, we're again going to start at our, because we've got one arrow, we're going to start with y, and then we got to decide, does it get bigger and go up, or does it get smaller and go down? In this case, it's going to get bigger and go up, so it's going to be greater than or equal to, and our line stops at 0. So again, our domain is also going to be all real numbers greater than or equal to 0. All right, I want you to try this one with a buddy. or try this one on your own and check it with the class notes. We're going to do this last one together. And this one is different because I've got 2 arrows. But it's going to be different for our domain and our range. So because our domain is the furthest to the left and the furthest to the right, I have 2 arrows. So 2 arrows is going to equal all real numbers. And so what all real numbers means is that this arrow is just going to keep going and going and going and going. So any number that we can think of, eventually this line, if it keeps going far enough, is going to hit those numbers. So for our domain, we literally draw our funky looking R, which is the same thing as all real numbers. So our range is not the case, because if we come all the way down, we do not have an arrow. That's just a point on a line. But if we go up, we have 2 arrows. So for range, we only have 1 arrow. So we have to go back to, oh, that's not a good bracket, to Y. And is it going up, which is greater, or down, which is less? So greater than or equal to, and that is -3. All right, I want you to try and write these inequalities statements into actual inequalities. And once you've tried it, I want you to check with the class notes to see if you're correct. Because a lot of the times on our tests, we see inequalities written as words instead of written as inequalities. So we have to make sure we know which words go with which inequalities.